Here are the explanations for the worksheet for section 2.5 proofs. So for this first proof, I tell you that angle DPW is 90 degrees and we want to prove that the two lines are perpendicular. So in order to prove perpendicular, we have to state that we have right angles, which is different than having 90 degrees. We start off with our given, and we know that since it's equal to 90, that is a right angle, so we clearly have to state that in words, and that's your definition of right angle. Once we have the right angle, that means we can say that our lines are perpendicular, and that's your definition of perpendicular. Remember that your definition of perpendicular only states that you have right angles. It doesn't have anything to do with the 90 degrees, and they are different until you have a proof to say otherwise. In the second one, we have two givens. We know RT is perpendicular to PQ and WY is perpendicular to PQ. You can split these up over two lines, or you can write both givens on one line, which is what I'm going to do here. So these are both given. There should be another line here. And what's happening is you're going to have to look at the diagram. So this is RT and PQ. So here we have our right angle. The box could have gone in any one of those four locations, but because the proof is asking about angle 1, that's why I chose to put it right there. Which is also how I know that angle 1 is a right angle, and that should go on this line. And the reason why I know that's a right angle is because I have this symbol above, and that's your definition of perpendicular. The same reason holds for why angle 3 is a right angle, and that's because the second part of the given states that WY is perpendicular to PQ. Technically, these all would be right angles, but what I need is this angle 3 because I'm trying to show that they're congruent, and this here is going to be definition of perpendicular. I have two statements that have perpendicular in them, which is why I can use that as my reason twice. The last line of the proof has to be the proof, so there's only one answer here, which is that angle 1 is equal to angle 3, and the reason why is all right angles are congruent. This was the first theorem in the notes I gave you on 2.5 that we'll actually use. It's a shortcut, otherwise we would have to say that angle 1 equals 90, angle 3 equals 90, and then state they're together. So this allowed us to skip two lines because we have that they're right angles, and we have a theorem that shows that all right angles are congruent. The next theorem we have our given, so we know that LM is perpendicular to SM. I'll fill in my box on my diagram, and I'll fill in my given information. Then it says definition, so the only thing I have right now is this perpendicular, so this has to be the definition of perpendicular. And what it means to be perpendicular is that I have right angles. So somewhere in this diagram, I need to state that I have a right angle. And if we look here, this is telling us what angle we need to talk about. If we're going to draw a conclusion, we could technically say both of these are right angles, but since the proof is using LMS, that is why I'm only going to focus on that in my proof. So angle LMS is a right angle. That's your definition of perpendicular. And now we know that if you're a right angle, or if an angle is right, then it has to equal 90, and that's the definition of right angle. The next theorem is going to go the other direction. And now what's going to happen is you know that you have a 90-degree angle, and this time we're trying to show that our lines are perpendicular. So in order to show that our lines are perpendicular, we have to state that we have a right angle and then they're perpendicular. These two are kind of like opposites of each other. It's the same thing, it's just the reverse. The proof is the reverse. So we know that KLM is 90 degrees, and that was given. Since it's equal to 90, we also can state that it is a right angle, and that's the definition of right angle. And then we know that KL is going to be perpendicular to LM, and that's your definition of perpendicular. For the last